In this video, I'll show you how I built a Git client with domain-driven design and the great architectures. Rather than focusing on rules and definitions, I'll explain my thinking process so you can take inspiration and apply it to your projects. Let's start. The application I built is a partial replica of a Git client, and I did it as part of a Codecrafters challenge. This is a learning platform where you're asked to build complex software like Git, Redis, or Docker. This challenge consists of 7 stages that you need to complete in order. You start by initializing a Git repository. Then you move into reading and creating Git objects. And finally, you perform a full clone of a remote repository. The very first thing I do in every project is understanding the domain by identifying the most important entities and relationships. The initial version of the model was very simple. Git stores data about a local repository in the form of compressed objects. Each object has a type, size, and content. In this challenge, we need to manage only 3 types: blob, tree, and commit. I also use 2 other constructs of tactical DDD, repositories and factories. The Git object repository was necessary to abstract the complexity of storing and retrieving objects from the data store. The factory was useful to create objects from raw bytes, which is something I didn't want to do in the entities constructors. But why did I go through the effort of creating a domain model? In a professional environment, the domain model is necessary to create a ubiquitous language, which is basically a shared understanding of what we're building. However, I find it useful also when I'm coding alone, because it helps me understand the relationship between different concepts and organize the code accordingly. This simple structure allows me to identify the commonalities between the different object types and avoid duplicated code. It also prevented me from fitting too many concerns in a single class. Last but not least, it helped me extend the feature set in the last stage, when I needed to map concepts like remote repositories, references, packs, and delta instructions. I want to highlight that I never invest too much time in making the model perfect or complete. I just need a high-level map of what I'm building. The level of detail I put in the model depends on the complexity of the domain and the stakeholders' expectations. If I'm working alone, the expectations are low. If I'm working in a professional environment, I obviously go much more detail. Another decision I take at the very beginning of a project is choosing an architectural style. In other words, I define the application layers and how they interact with each other. There are 4 architecture styles I always take into consideration. However, rather than choosing one of them, I just make sure that my application doesn't break their principles. In fact, I cherry pick from each architecture what I find useful, according to the scenario I need to solve. For this challenge, I decided to stick to a classic 3-layer architecture and detach the business logic of my application from infrastructure and user interface. I named core the package containing all the domain model and the business logic. This is in line with the definition of application core given in the Onion architecture by Palermo. Clean, Onion, and hexagonal architecture also highlight the importance of ensuring that the business logic has no direct dependency on any other layer. In practical terms, it means that any class you place in the core cannot import classes from other packages. But how can we store data on the database without having a dependency on it? The way I keep the core layer dependency free is using the hexagonal architecture and its concept of ports and adapters. Even though you'll not find any class in this particular codebase named port, or adapter, I am always very aware of what my primary and secondary ports are. In this application, the Git object repository and Git remote repository are examples of output or secondary ports. They describe the protocol the application uses to interact with the infrastructure and remote services. On the input or primary side, you'll notice I was naughty and created no interface. Instead, I declare the ports as concrete use cases. However, they still represent the gateway to the core logic for other layers. In a real-world project, I'd be more strict and define interfaces before moving to the implementation. Another interesting decision I made was to prefer use cases to multipurpose service classes. This is what Uncle Bob suggests in his clean architecture. Domain entities, value objects, or aggregates are not sufficient to implement all the business logic. You typically need a set of services where you place all application-specific logic you couldn't fit elsewhere. Typically, this includes orchestration of factories, collections of entities, and repositories. It's very common for development teams to define service classes named after the most important entities. If I have a Git object class, I could go ahead and create a Git object services class, where I orchestrate the interaction between the different objects I define in the model. That's fine. However, in my experience, it leads to code that's not very expressive. Use cases instead focus on delivering a single reusable feature. For this reason, they are way more expressive and tend to be more stable. Once implemented, there are less factors that can force you to modify an already delivered feature. When it comes to frameworks, you should avoid them in the core package if you want to apply clean, onion, or hexagonal architectures in a very strict sense. This is very difficult if you have a project that relies on frameworks like Spring or Django. It'll be very painful to avoid using it in the core layer. As usual, use your discretion and figure out what's best for your team. The very last thing I want to mention is testing. Even though I always believed in test-driven development, my advice is don't stress too much about it. Doing TDD properly requires some skills and practice you cannot build overnight. TDD is also a bad choice if what you're building is exploratory or experimental, which was the case of this Git challenge. That said, don't overlook testing. Despite my low test coverage, I know for a fact that I had exactly the right amount of testing I needed, and that allowed me to refactor the code several times and test several patterns, like the decorated pattern or the strategies. Testing is all about validating what you built and having the confidence to refactor it. Without a proper test suite, you'll be very reluctant to update your codebase because you have no way to guarantee that your modifications won't break the application. Summing up, I always create a lightweight domain model of any application I build. With modern diagramming tools like Mermaid, there is no excuse to skip this step. The benefits are multiple, but the most important is that it delivers a very quick understanding of what we're building. The architectural style doesn't matter. Don't try to choose between clean, onion, or hexagonal architecture, with the idea that you're going to replicate the layers exactly as described in their diagrams. What matters are the principles behind those diagrams. The most important is keeping your business logic decoupled from concerns like UI and infrastructure. Finally, don't underestimate the importance of testing. It's not necessary just to limit bugs, but also to allow us to extend and improve our code base over time. Last but not least, share this video with your colleagues so that everyone can learn something new.